Good morning, everyone. My name is Nisrina Amri, and today I'm going to deliver the presentation of my paper with the title of Laundry System Optimization on an In-Flight Service Company. Nowadays, the most favorite things to do is traveling during holidays. Airline industry has increased because many people would prefer air transport rather than land or water transport as it is convenient, affordable, and the fastest way to go anywhere, especially when having a plan to traveling abroad. Because airline industry offers in-flight entertainment, in-flight meals, and in-flight comfortability. Everything that are provided by the airline companies are managed carefully as well as its hygiene, its cleanliness, value, and treatment. There are laundry companies designed for airline materials. As one of SC's customer is an in-flight service company, which is Aerofood. The research problem on this paper is, first, there was no schedule for laundry system within the company. And the second one is there was also no rules which materials should be assigned to which machine. As long as the machine is vacant, the workers put any materials to any machines that is vacant at the moment. And the third one is while doing loading and unloading process of the materials, some workers are not only doing the load and unload process. Sometimes the workers are wandering around or set up the machine and or back to the queuing area or buffer area to take more materials as the machines are not full yet or have not reached the maximum capacity of the machines. The fourth one is there was also a bottleneck after washing process is finished. The longest waiting time is reached up to 5 minutes. As the company was planning to buy more machines, the objective of this research is to determine whether the number of resources is sufficient by developing a schedule and doing optimization for washing and drying process using linear programming as the company planned to buy 2 washing machines and 3 dryers that help the company in deciding whether they need to buy more or not. And if yes, how many machines should they buy? The research methodology starts with by identifying the problem, and after knowing the problem, search any theoretical methods from papers, journal, and textbook that could help in supporting the research of this paper. And next, developing the mathematical model as it can help in suggesting the data needed that have to be collected for solving the problem, and then collect data before proceeding the optimization. Process the data by optimizing using solver to find an optimal solution and develop a Gantt chart. And then develop a simulation for verifying the result of optimization, whether it is applicable or not in minimizing the max span. If it's not valid, then rebuild the mathematical model. And if the simulation shows the optimization result is valid, analyze the result and make a conclusion and recommendation for the company. For the optimization, mathematical model is needed. The objective function is to minimize the max span of the operation time within a day by maximizing the remaining time. The operation time within a day is 21 hours, as the company has 3 shifts working hours with 1 hour break each. M here represent the laundered materials. Minimizing max span which lead to maximize the remaining time. Here are the HT represent as total working hour in 1 day, and N in number of machines, and TP materials process time in each machine. Here are the constraints of the mathematical model and its parameters. Here is the comparison table of the optimization result. As seen in the table here, it shows that by adding one more tumble dryer, it could increase the daily demand capacity by 160 kilogram. This Gantt chart is developed to verify the result of resource allocation using the linear programming. As you can see here, the yellow box represent as the white linen, the blue box for blanket colored, the green one is colored linen, and the brown one face towel, and the gray one is represent as that the machine is vacant at the moment. This is the simulation for the optimization. The simulation is also used to verify that the optimization result is valid. This also shows the optimization result with the number of workers. And in washing area, the workers are 3% and dryer area are 2. In additional machine version, it is added to more percent. And this is the comparison table of the simulation result. It shows that with the additional tumble dryer, the operation time is reduced by 1 hour from 20 hours 46 minutes to 19 hours. The remaining 2 hours can be used for additional demand or unexpected events. And the conclusion for this paper is linear programming approach with assignment model and transportation model are chosen to decide which material should be done in which machine. This helps in developing schedule for the laundry system that leads in minimizing the total operation time of 21 hours in a day. The optimization using linear programming is applicable as it is shown in the simulation for both demand in 11,000 kilogram and 13,000 kilogram in a day. In this simulation, the difference of output and simulation are slightly different compared with the result of optimization. The second one is, if the demand in the company reaches up to 13,000 kilogram per day, the company will have to buy one more tumble dryer in order to minimize the total operation time in a day and meet the customer's requirement just in time without being delayed. And based on the result, there are several recommendations suggested for the company. First one is the company needs to buy more tumble dryer. So during the peak time, the demand could reach up to 13,000 kilogram per day. The second one is the company should hire 2 more workers for the drying process. And the third one, Aerofood needs to create regulation for materials and machineries assignment in order to increase the productivity level and save more time in one day of the laundry system. The fourth one is, as a consulting company, ASIS should develop a program to determine Aerofood's laundry system that could help them in increasing the productivity level. And the last one is, Aerofood needs the development of a system to apply new rules, especially in determining the schedule of laundry system and the unloading and unloading process for the workers. That's all from my presentation. Thank you for your attention.